Hey guys, this video we're going to talk about adding and subtracting radicals. So we're going to look at problems that look something like this. These are the problem types we're going to investigate. So as a reminder, the best way to use these videos is to pause and try the examples when prompted. And I do have free guided notes available. And just giving really myself a shout out, if this is helpful, please consider liking the video or commenting or subscribing to the channel. I'm trying to build this channel out, so if you like the free math help, it just helps me out if you take a moment to do that. Okay, so where we're going to start actually is with review. This is something that you need to know to be able to do this. So if you have no idea how to do these problems, I have some links to videos in the comments, because this is a skill you need to feel pretty comfortable on before you get started. Otherwise, just pause and hit play when you're ready. So for this first one, so I have to simplify this square root. So if I think about what are the largest squares that I can factor with this, so I can actually factor out, so this 4, x to the 6, and y to the 8th. Things that I cannot simplify are going to be 6y. So my final answer here is 2x to the 3rd, y to the 4th times the square root of 6y. And then for this other one, so the 4th root of 16, so I can actually simplify just that as is. And then I can also simplify x to the 4th and y to the 8th, but what I cannot simplify will be the 4th root of x to the 3rd, y to the 3rd. So this will ultimately equal 2x y squared times the 4th root of x cubed y cubed. So those are going to be helpful just for kind of getting us warmed up here. If you're doing this and you're like, I'm not really too strong on this, you really should go back and watch the video, because otherwise this is going to be very, very difficult. So you want to definitely be very strong on this before we get started. Okay, so first things first, another thing I want to talk about with review, what are like terms? So, like terms are terms that have the exact same variables with the exact same exponents. Let's put an S there. And only like terms may be added or subtracted. So this is something that you should also know before you start this. So I just have a very quick exercise just to kind of jog your memory. Again, this is all going somewhere. So pause the video and hit play when you're ready. So if I just add up my like terms, so this will be 7y squared plus 5y minus, let's see, so I have 3x minus 9x minus 2x, so let's see, that looks like that's going to give me negative 8x. So there would be all my like terms. And so just to kind of give you a quick run through of that, so the like terms here, so the y's are definitely like terms, the x's that we see here, these are all like terms, and then this last 7y squared, so it has no other like term, it just stands by itself. Now, if you put this in a different order, that's totally fine, but these are the three things that you need, and the 8x has to have a negative in front of it, so that's kind of the important thing here. Okay, so this is what the idea of like terms is, so hopefully we're good on that. So now I want to talk about the idea of like radicals. So like radicals are very similar, that's why we started with this. They have the same indices, and they'll also have the same terms in front, and only like radicals may be added. So with that in mind, so here's kind of the same, here's a similar example. So I'll go through this one with you. So as I look through this, so notice I've got square root of 3, cube root of 3, cube root of 3, square root of 5, square root of 3. And I just have numbers in front of all of these. So the like radicals in this case, so anything with the square root of 3, that will be a like radical. So I've got this one and this one down here. And then I've got the cube root of 3, so that would be this one and this one. And then this one just kind of stands out on its own. So when you add these, you're just adding the numbers in front, just like you would with like terms. So just to be nice and clear with that, so the terms I underline in green, so 5 plus 8 is 13, so this will be 13 times the square root of 3. Then negative 2 plus 8, so that'll give me 6 times the cube root of 3. And then finally this last one, that just stands by itself. So that's all you'll do with that. You don't do anything with the radicals, they just kind of come along for the ride. So with that in mind, pause the video and try these. I know that they look a little bit longer, but I think that they will really drive home kind of some of the tricky parts with this. Okay, so looking for my like terms here, or my like radicals. So I've got 4 times the square root of 7. I don't have that again, so that one's by itself. Then I have this cube root of 3, and I have this cube root of 3 over here, okay? And then I've got the square root of 3 and the square root of 3. And then here I've got this cube root of 7. So it just kind of depends on the problem how many like radicals you're going to have, so you just kind of have to think about it. So let's see, I'm going to start with just 4 times the square root of 7, so I can't do anything with that. Then I'll do this negative 5 times the cube root of 3 plus the cube root of 3, so there's an invisible 1 in front of this. So this will be minus 4 times the cube root of 3. And then I've got this 2 times the square root of 3 minus 9 times the square root of 3, so that's minus 7. And then this last one. And again, the order doesn't matter, just so long as you have all the right signs in front of everything. That's all that's really important here. So there's the idea. Now this one we have to be a little more careful. We actually have kind of like terms and like radicals we have to worry about. So when I look at this, so this has 2x and the square root of 7. So even though this has the square root of 7, it doesn't have the x in front, so it can't actually be combined. So I have this one, that would be the one that could be combined, while these two could be combined. So you just have to kind of watch out for that. And so then I have 2x plus 8x, so that's going to be 10x times the square root of 7. And then negative 3 minus 2, so that'll be minus 5 times the square root of 7. And then I have this one, which is a little bit of a monster, but it really drives home again that point. So I've got this 3x times the cube root of 5, and if I look through this, so let's see, I can also take this one. Any others? I think that's it. And then 2x times the cube root of 4, and 5x times the cube root of 4. And then I also have these. So that's what I can combine. So I'll start with the blue terms here. So this will be negative 4x times the cube root of 5. And then the next one, I'll go with these pink terms here. So this will be plus 7x times the cube root of 4. And then finally, plus 2 times the cube root of 4. So you just kind of want to watch out for that as you're working through these problems. Okay, so switching gears, now let's talk about this type of problem. So this is also a very typical type of problem that you'll add for adding like radicals. So notice with these, you can actually simplify each of these. So you should be very comfortable with this before you get started. So the square root of 24, so if I just simplify that, that will be, so this has got the largest square root that will divide into 24 is 4. So I can really break that down as 4 times 6. And then for this other one, so the largest perfect square that will divide into 54 is 9. So this will be 9 times 6. So I've rewritten this just by kind of breaking this down. And so I get 2 times the square root of 6 plus, 2 times 3 times the square root of 6. So these then you'll just multiply together. So ultimately I get 2 times the square root of 6 plus 6 times the square root of 6. And now I can add my like radicals to be 8 times the square root of 6. So sometimes these are going to have some extra work in them, and you just kind of have to watch out for it. So here are 2 basic ones just to kind of let you give this a try. So hit play when you're ready. So this first one, so this will be 5, so the largest perfect square that goes into 8 is 4, so this will look like this. And then for this other one, so this will be 9 times 2. So then I get 5 times 2 times the square root of 2 minus 3 times the square root of 2. So I ultimately have 10 times the square root of 2 minus 3 times the square root of 2. So this is 7 times the square root of 2. Now for this one, I have to think about cubes here. So the largest perfect cube that will go into 54 is 27. And then the largest perfect cube that will go into 16 is 8. And now I can go ahead and work through this. So I've got 4 times 3 times the cube root of 2 minus 7 times 2 times the cube root of 2. So ultimately I have 12 times the cube root of 2 minus 14 times the the cube root of 2. And so if I subtract those, I get negative 2 times the cube root of 2. Okay, so now what I want to recommend is that you try all of these. You might feel like you're good, but actually this can get pretty dizzying with letters. So I have all of these. I know it's a lot, but I think it'll really be beneficial to you if you give them a try. So hit play when you're ready. So starting with this first one, so you have to just kind of scan and see how far can you actually simplify this. So in looking at this, this part here cannot be simplified any farther, but this one can be simplified. So if I just think about with this first part, so what can I simplify? So 4x squared and y to the 4th, but I'm still going to have this other factor of 2. And there's nothing I have to do to the second part of this problem. So then this becomes 2x y squared times the square root of 2 times 9xy squared times the square root of 2. And now I can see that I can actually subtract these. So this is negative 7xy squared times the square root of 2. Okay. So moving on to this one. So once again, you just kind of have to scan and see can you simplify any farther. So with this one, I can break this down for sure. And then this one can also actually be broken down. So there's kind of a lot going on here. So let me do this actually in 2 separate colors just to make it nice and clear. So for this one, if I break this down, so I've still got that 4x in front. So the part that I can break down further in here, this is 8x to the 6, y to the 6, but the part that I cannot break down will be 2y. And then I'll do this next part in pink. So this is 9 x cubed y times the cube root of 125y cubed times the cube root of 2y. Okay, so now I'll keep working through this. So this first part will be 4x times 2x squared y squared times the cube root of 2y. And then this next part will be 9x cubed y times 5y times the cube root of 2y. And so now if I simplify all of this, so this becomes 8x cubed y squared times the cube root of 2y plus 45x cubed y squared times the cube root of 2y. And so now taking a look at all of this, so then I can actually combine these, right? So 45 plus 8, that's going to be 53x cubed y squared times the cube root of 2y. So there's actually quite a bit that kind of goes into this. Okay, so are we having fun yet? So now what I want to do is I want to show you another way you can kind of do this. So if you found the way that I did the last one overwhelming, so some people just don't like doing all of the detail together line by line. I am somebody that just likes to kind of have it all there and I can kind of compartmentalize it, but not everybody can. So I'll just show you another way that you can do this, just a different way to organize information. What makes these hard is it's just so much to look at. And so you have to really decide what is the best way for you to do it so that it makes sense in your brain. That's like half the challenge, I think, with math. So what I'm going to do is I'm just going to work on this one here. I'm underlining it in green. I'm going to work it all the way out, and then we'll just kind of shelf that answer and come back to it later. So starting with this, so I've got 5x squared y to the 3rd, so that's just going to hang out. Now what I want to do is I want to factor out the parts of this that I actually could evaluate. So that would be the 4th root of 16 x to the 4th and z to the 8th. And then the parts of this I cannot do anything with will be 2x cubed z squared. Okay. So now I will go ahead and I will just evaluate this. So this first part is just going to continue to hang out. So we're just going to write this as 5x squared y cubed. Now multiply this by, so the square root of 16 is 2. The 4th root of x to the 4th will just be x. And then the 4th root of z to the 8th will just be z squared. Okay. And then this last part, like I said, I can't do anything with this. Okay. So now I'm going to multiply this part together. So this is 10 x cubed y cubed z squared times the 4th root of 2x cubed z squared. All right, so now what I want to do is I want to clear some room for myself, so I'm going to just move this part of the answer up here, and then we'll press on. Okay, so there is my first answer. So now let's work on this second part. So again, in just looking at this, so first this part in front is just going to hang out. So this is 2x cubed z squared. Okay, so that's going to hang out. Now this part in here, what can I actually simplify farther? So it's just actually the y to the 12th. So this will be times the 4th root of y to the 12th. The rest of the stuff I can't do anything to. So if I go a little farther with this now and evaluate this part here, this will give me, so this 2x cubed z squared times y to the 3rd, and then this is the 4th root of all of that stuff still. Now, as a best practice, I like to always put my variables in alphabetical order. So I'm going to write this now as 2x cubed y cubed z squared times the 4th root of 2x cubed z squared. All right, so now let me clear this off so I can just see what problem we're left with. Okay, so I'm running out of room here, but so this was the simplification of this part, and this was the simplification of this part. So basically what you want to do then is you just want to kind of remember what operation were you doing with them. So I am subtracting this part off. So that could be another way to do that, is just work it out and then put it back together to see what you've got to do. And I actually do have, you know, like terms like radicals, so I'm all good on this. So this will ultimately end up being just 8x cubed y to the 3rd z squared times the 4th root of 2x cubed z squared. Okay, so we have this last one here. So I'm going to do it in very much the same way I did the last couple. So let's see, I will go ahead and just break this down and work it out all the way just like I did in the last problem. So for this one, so the largest cube root that goes into 24 is 8. I can pull out an x to the 3rd and a y to the 6th. And then what's left over, this will be 3x squared y. So if I work this out of the way, so I'm leaving this 3x in the front alone, multiplying this by 2x y squared, and then I have this part that I cannot do anything with. So ultimately I get 6x squared y squared times the cube root of 3x squared y. Okay, so there's my first part. Now I will go ahead and just, so let's look at the next one. So this one, actually, I don't have to break this one down any farther, so I'm actually just going to leave this alone. So I will just kind of put an underline here, so that one's done. So that's a reminder for myself to come back to this later. So I've got my first answer here. I've got my second one that doesn't need anything. Now let's just go ahead and simplify this part. So I will do this in blue. So I've got y squared, I'm leaving that alone as far as what I can actually break down. So I could pull out a 125 x to the 6th, and then I'll still have this cube root of 3x squared y. And so if I break this down farther, so this will ultimately come out to 5x squared y squared times the cube root of all this stuff. Okay, so I've got kind of all the pieces that I need. So I need this piece here, and I need this piece here, and I need this piece up here. So let me clear some space now for myself and actually go through and start adding this together. So if you're playing along at home here, so you would just have these probably boxed up on your piece of paper. I'm just kind of running out of room. So now I want to actually write down what am I adding? What am I actually doing? So I'm just going to write all of these pieces in the boxes now. So I've got 6x squared y squared times the cube root of 3x squared y plus 3xy times the cube root of 3x squared y, and then all of that plus 5x squared y squared times the cube root of 3x squared y. Okay, hopefully you can see that. Starting to get a little smushed here. So as far as what my actual like terms and like radicals go, so notice actually this and this are the only like terms like radicals. This has x squared y squared, this does not, so this actually cannot be combined. So you do want to kind of stay on your toes when you're doing this. So my final answer will be 11x squared y squared times the cube root of 3x squared y plus 3xy times the cube root of 3x squared y. And so that'll do it. So hopefully you are feeling all good about this. Please comment, like, and subscribe if you found this video helpful, and I will see you guys next time.